The provided hexadecimal program for Dragon0 is indeed very similar to the one previously analyzed, with only minor differences in the disassembly. The core question is, whether this version of the program is more understandable, and I'll address that by comparing it to the previous listing, analyzing any improvements in clarity, and providing a refined explanation of what the program does for your 1982 Clasoft basic game on the Apple II, running on a Motorola 6502 processor. Comparison with the previous listing. The two listings are nearly identical, both spanning from $800 to $0 BFF and containing the same sequence of bytes for most addresses. However, there are subtle differences in the disassembly, likely due to variations in how the disassembler interpreted certain bytes or opcodes. Key observations. 1. Disassembly differences. Invalid opcodes MVP. Both listings contain MVP instructions E.G, $848, $870, $8 C9, which are not valid 6502 opcodes. This suggests either data sections being misinterpreted as code or errors in the program itself. The new listing doesn't resolve this issue, so it doesn't inherently improve clarity here. Instruction interpretation. At $830 and $833, the new listing shows ICCCC followed by TSB0000, while the previous one had I0CCC. This suggests a slight difference in how multi-byte operands are parsed, but the actual bytes CCCCCC0C are identical. At $879 and $87 F, the new listing clarifies some instructions, int 02x, or 06s, y, and 14, cop00 versus the previous ASL34, cop13, ASL25, TRB02. The new interpretation seems more plausible for some instructions, but others E.G, cop00 are still unusual for a 6502 program, as cop is a 65C02 specific instruction not typically used on the standard 6502 in an Apple II. At $96 G, the new listing has $40, where the previous had a BRK40. This could indicate a correction or a different disassembler assumption, but it doesn't significantly change the program's behavior. JSR $2020 sequences. Both listings have large blocks of $20 2020 E.G, $0 A50 and $0 A74, $0 AD2 and $0 F6, interpreted as JSR 2020. These are likely dated, not code, as $2020 is in the middle of the Apple II's higher ease graphics page 1, not a typical subroutine address. The new listing doesn't clarify this, so it remains a point of ambiguity. 2. Byte level consistency. A spot check of the hexadecimal bytes shows they are identical between the two listings for most addresses. For example, $846 and $854, 0, 4, 44, 44, 44, 44, 4, C, 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 BB1, B91, 99, 0, 9, 0, 0 in both. $9 D1 and $9 E0, F9 F0, 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 F0 in both. The differences are primarily in how the disassembler labels or interprets these bytes, not in the program's content. 3. Clarity. The new listing doesn't significantly improve understandability. The persistent MVP errors and ambiguous JSR $2020 instructions remain problematic. The slight changes in instruction interpretation E.G, int versus ASL, RT versus BRK don't resolve the core issue that large sections appear to be data rather than executable code. The program's structure and mixing apparent code or a MEP stat JNP with data like patterns $44, 44, $44 C, 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 $20, 2020 and suggests it's a machine language routine with embedded graphics data, but the disassembler's misinterpretation of data as code obscures its purpose in both listings. Refined analysis of Dragon0. Given the near identical nature of the two listings, the program's purpose remains consistent with the previous analysis. Here's a refined explanation of what dragon0a does, incorporating insights from both listings and addressing the Apple II, Applesoft Basic, and Motorola 6500 to context. Program purpose. The dragon0a program is a machine language routine for an Applesoft Basic game from 1982, designed to run on an Apple II with a Motorola 6502 processor. It likely handles rendering and or animating a dragon sprite on the high-resolution HDR graphics screen 280 x 192 pixels, 1-bit color with color artifacts. The program is loaded into memory at $800 2048 and called from Applesoft Basic via call 2048. It performs tasks that are too slow for Basic, such as drawing or updating a game sprite. Key components. 1. Graphics data, bitmap patterns, sequences like $44, 44, 44, 44 E.G, $848 and $84 B, $870 and $875 $, C, 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 E.G, $830 and $833, $916 and $91 C, and $F0, F0, F0. F0 E.G, $9 D4 and $9 E are characteristic of sprite or tile data for the Apple II's HDR mode. Each byte represents 7 pixels. The high bit often determines the color group, purple/green or blue/orange. Example, $44 binary 01000100 might render a pattern like X, X, where X is a pixel, forming part of a dragon's shape. E.G, body, wings, or head. $CC binary 11,001,100 could represent 20th, possibly for a figure or pattern part of the sprite. Sprite hypothesis. Given the program's name, these patterns likely define the dragon's visual appearance, possibly a single frame or multiple animation frames for a dragon character, enemy, player, or decoration. Data sections. The long runs of $20 2020 E.G, $0 A50 and $0 A74 are likely padding, a text buffer ASCII space $20, or misidentified sprite data, not executable JSR instructions. 2. Executable code, initialization/setup. The program starts with aura 0000 F0 $800, which may read or modify a 0-page variable or I/O location. E.G, $0 F0 could be a game state or graphics pointer. Loops and branches. MEA instructions. E.G, $820, $822, $895, $897, $911. Create loops, likely for iterating over sprite data or updating screen memory. For example, MEA 07 F2-30 at $820 branches backward, suggesting a tight loop. ECPI instructions. E.G, ECPI number CC at $82 E, ECPI CCCC at $830. Compare the Y register, possibly indexing through sprite rows or columns. Graphics manipulation. Stan 99, Y. E.G, $852, $8 B4, $8 G2 stores the accumulator to a memory location offset by Y, likely writing pixel data to the HDR screen $2,000 and $3 F. TSB test and set bits. E.G, $846, $8 C7, $97 A and TRB test and reset bits. E.G, $97 C, $0 A7 A manipulate specific bits, common for setting or clearing pixels in a sprite. Ashley.G, $9 A and bit. E.G, $879 suggest bit shifting or testing, possibly for aligning sprite data or checking pixel states. Control flow JNP $06310 B7B JNP $090 F0 BFAT and JSR 087 F0 aft indicate jumps to subroutines or other program sections, possibly for initialization, drawing, or exiting the routine. RT at $96 D new listing or BRK40 previous suggests a return to basic or an interrupt handler, though it's unclear without context. 3. Integration with Applesoft. The routine is likely loaded with load dragon0a and invoked with call 2048 from Applesoft Basic. It may read parameters. E.G, Sprite position or frame number from 0 page memory $0 F0 or basic variables via pointers. The program returns control to basic, possibly via RTS not explicitly seen but implied or T96 G. For anomalies, invalid opcodes, the MVP instructions E.G, $848, $870 are not 6,502 opcodes and likely indicate data bytes misparsed as code. For example, $44 44 is probably a sprite row, not MVP 4444. JSR $2020. The repeated $20 2020 sequences are almost certainly dated, not jumps to $2020, as this address is in HGR memory. They could be spaces in a text buffer or padding. BRK overuse. The numerous BRK00 instructions E.G, $804 and $81 C may be padding or intentional halts, but they could also indicate an initialized memory or a disassembler misreading. Functionality. The dragon0 program is a machine language routine that renders a dragon sprite, copies bitmap data E.G, $44 $CC $F0 patterns to the HGR screen to display a dragon graphic, likely 8 and 16 pixels wide / tall based on the data size. Handles animation / movement, uses loops BNET, and bit manipulation TSB/TRB to update the sprite's position or cycle through animation frames. Supports game logic, may check or update game state E.G, via Aura 0000 F0 SBC for sprite positioning, collision detection, or status. Integrates with BASIC, called from a +off to perform fast graphics tasks, returning control after completion. Is this listing more understandable? The new listing is marginally more understandable due to slightly better instruction interpretations in some areas. E.G, PIT02X versus ASL 34 at $879, but it doesn't resolve the core issues, persistent ambiguities. The MVP opcodes and JSR $2020 sequences remain confusing, as they misrepresent data as code. No new context. The listing doesn't provide additional clues about how the routine is called or what the game does, so the overall purpose is still inferred from patterns and AppleSecond conventions. Minor improvements. The RT at $96 D and some opcode clarifications. E.G TSB 0000 at $833 align slightly better with expected 6,502 behavior, but they don't significantly change the program's interpreted function. To make the program truly more understandable, you'd need correct disassembly, a disassembler that distinguishes data from code. E.G, treating $44 as sprite data, not MVP. Context. The +oft basic code that calls dragon0 or details about the game's mechanics. E.G is the dragon a player, enemy, or static graphic. Point. Memory map. Information on what $0 F0 $87 F $90 F or $631 reference. E.G variables, subroutines, or I/O. Answer. The dragon0 program is a machine language routine for your 1982 +oft basic game on the AppleSecond, running on a Motorola 6502 processor. It renders and possibly animates a dragon sprite on the high-resolution graphics screen, using bitmap data. E.G $44 $CC patterns and instructions like stat ESB and BNET to draw and update the sprite. Called from a +oft via call 2048, it handles fast graphics tasks. The new listing is slightly more understandable due to minor improvements in disassembly. E.G PIT versus ASL, RT versus BRK, but persistent issues like invalid MVP opcodes and misparsed data. JSR $2020 limit clarity. The program's core function drawing a dragon sprite remains the same as in the previous analysis.